In this video, we're going to do some more evaluating with our double angle identities, except this time our angle is unknown. So this will require us to draw some triangles. All right, so number 1 says, given the tangent of theta equals negative 15 over 8, and 0 is less than theta is less than pi, find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So the first thing that we want to do is draw a triangle to figure out exactly what we're dealing with. So we're given two things to help us figure out what quadrant we need to draw those in. First of all, our tangent is a negative value. If you remember from the unit circle, your tangent is always negative in quadrants 2 and 4, where your sine and cosine have different signs. Okay, so quadrant 2 or quadrant 4 based on this. But we also know that theta needs to be between 0 and pi. Remember, 0 and pi, if we're going to be between 0 and pi, we're in the top half of our unit circle. And quadrant 2 is the only one of those quadrants that's in the top half of our unit circle. So that's where we're going to draw our triangle. So I'm going to go ahead in quadrant 2 and draw a right triangle. Remember, when you draw these triangles, you always form them with the x-axis, not the y-axis. So I'm going to put theta here. Now we're given tangent. Tangent is opposite over adjacent. So we know our opposite side is 15, and our adjacent side is 8, and we know that one of those has to be negative for the tangent to be negative. If we're in quadrant 2, remember it's the x that's negative and the y that's positive. So the negative actually goes on the 8, even though in the problem it looks like it's on the 15. Okay, so when you're given a negative tangent, remember that it could be either one of those numbers based on what quadrant you're in. Okay, so now we are ready to find our third side of our triangle using the Pythagorean theorem. So we've got negative 8 squared plus 15 squared, and I'm just going to put h for hypotenuse. All right, so I'm going to pull out the calculator. Negative 8 squared is 64. 15 squared is 225. And then we've got 64 plus 225 is 289. And then when we square root 289, we get 17. So our hypotenuse is 17. That's also a Pythagorean triple. 8, 15, 17 is a triple. So maybe you noticed that right off the bat. Remember that your hypotenuse, or the slanted side of your triangle, should never be negative on these problems. All right, so let's find the sine of 2 theta using our formula, 2 sine theta cosine theta. And we're going to get our sine theta and our cosine theta by looking at our triangle. So remember, sine is opposite over hypotenuse, so that'll be 15 over 17. Cosine is adjacent over hypotenuse, so that would be negative 8 over 17. And then we're just going to multiply. Now keep in mind that 2 in the front is like a numerator, so we're going to do 2 times 15 times negative 8, which gives us negative 240 on top. And on the bottom, it's just 17 times 17, which is going to be 289. And then you always want to see if your numbers will reduce. So negative 240 divided by 289, and change that to a fraction, and it doesn't reduce. So that is our sine of 2 theta. All right, now let's do cosine of 2 theta. And at this point, you can use any of these cosine formulas, because since we have a triangle to go from, we can get sine and cosine, or we could just do sine, or we could just do cosine. It doesn't matter. I just like using the first one if I'm able to. If I have both pieces of information that I need, I just typically use the first one. So this is cosine squared theta minus sine squared theta. All right, so what is the cosine? The cosine is negative 8 over 17. So we have negative 8 over 17, and we're going to square that. And then the sine is 15 over 17, and we're going to square that. Okay, so negative 8 squared is 64. 17 squared is 289. 15 squared is 225. And 17 squared is 289. Now, it should work out on these problems that you're going to have a common denominator here. So in the numerator, we just need to do 64 minus 225, which gives us negative 161. So negative 161 on top, 289 on the bottom. Just see if that reduces by chance. And it doesn't, so that's our cosine of 2 theta. All right, for the tangent of 2 theta, again, you can use the tangent identity, or you can do sine divided by cosine. Since I already have those two, that's what I'm going to do. So I have negative 240 over 289 divided by negative 161 over 289. Remember that the 289s are going to cancel, so I'm going to get 240 over 161. The negatives are going to cancel as well. And then just make sure that doesn't reduce to anything smaller, and it doesn't, so that's the tangent of 2 theta. Okay, for number 2, I'd like for you to try to pause the video and see if you can get number 2 set up correctly as far as drawing your triangle in the right quadrant and getting everything labeled correctly, and then resume the video and see if you've done it right. Okay, so we're told that the sine of theta is negative 1/3. Sine is negative, sine is your y value, so your y value is negative in quadrants 3 and 4, the bottom half of the unit circle, okay? But we're told that theta's got to fall between pi halves and 3 pi halves, so it's got to be greater than pi halves, but not as great as 3 pi halves. So that's the left side of your unit circle. That's quadrant 2 and 3. So the one that they both have in common is quadrant 3. So we know when we draw this, we're going to draw our triangle down in quadrant 3. Sine is negative 1/3. Sine is opposite over hypotenuse. So negative 1/3, and that makes sense because your number should be negative when you're going down. All right, put your theta there at the origin, and then we're going to have to find that missing side. So I'm just going to call that x, since that's going to be our x value going left. So we have x squared plus negative 1 squared equals 3 squared. So x squared plus 1 equals 9. If you subtract the 1, you're going to get 8. And then when we square root the 8, remember 8 branches into 2 and 4 and 2 and 2, so we get a pair of 2's that we're going to pull out front. So it becomes 2 square root 2. And it's also going to be negative because we're going left. So this side is negative 2 square root 2. All right, let's find the sine of 2 theta. So 2 sine theta cosine theta. The sine of theta we were given, negative 1/3. And then the cosine of theta, remember, is adjacent over hypotenuse. So this will be negative 2 square root 2 over 3. All right, so let's multiply that out. In the numerator, you have a 2 times a negative 1 times a negative 2 square root 2. So that's going to give us positive 4 square root 2. And then on the bottom, 3 times 3 is 9. So 4 square root 2 over 9 is the sine of 2 theta. Okay, cosine of 2 theta. We'll do cosine squared theta minus sine squared theta. Okay, so the cosine of theta was negative square root 2 over, negative 2 square root 2 over 3. We're going to square that, and then the sine is negative 1/3. And we're going to square that. All right, now be careful when you square this portion. When we square a square root, it takes it off. So this part right here will just become a 2. But then we also have to square the negative 2 out here, which would become a 4. And 4 times 2 is 8. So we're really going to get 8 over 9 minus 1 over 9. So be careful squaring this. You have to square the whole number, which is what gave us 4, and then you have to square the square root, which is what gave us 2, and 4 times 2 is 8. And then here you have 8 minus 1 is 7/9 for the cosine. Okay, and then for the tangent, we're just going to do sine over cosine. And remember, the 9's are going to cancel, so the tangent's going to be 4 square root 2 over 7. Also, when you're doing these, your sine 2 theta and your cosine 2 theta should come out to have the same denominator so that they do cancel out nice like this each time. If you ever get a sine and a cosine with different denominators, just double check your work.